Good morning, friends. Today's new lecture is on topological space. Housdorff space. What is Housdorff space? This Housdorff space is very important in topological space and metric space. The definition of Housdorff space is Housdorff space in a topological space. Suppose X to be a topological space and X and Y are two distinct points of ground state X. X and Y are two distinct points of X. Then there exists a pair of open sets G and H. There exists a pair of open sets G and H such that X is contained in G and Y is contained in H. That is, G contains X and Y contains H contains Y. G contains X and H contains Y. X belongs to G and Y belongs to H. And G intersection H is equal to 5. G intersection H is equal to 5. It means these two open sets have no any common point, so these are separated. So it is called separated space also. So a Housdorff space is a separated space. It is also called T2 space because it contains two distinct points X and Y. Proof. Now there is a question on this Housdorff space, which is very important question is prove that every metric space is a Housdorff space. Prove that every metric space is a Housdorff space. We have to prove that metric space goes to Housdorff space. Every metric space approaches to Housdorff space. For this, we have to prove is let X be a metric space. Let X be a metric space and J be the metric topology of the matrix. For it, we take 2 points X and Y. These are two distinct points of X. And we next consider epsilon is equal to dxy. Since here there is needs of open sets, so we consider two open spheres having center X and Y with same radius epsilon by 2. Just see here, these two spheres having center X and Y but having radius same epsilon by 2 epsilon by 2. So this is called epsilon by 2x and epsilon by 2y. We must have studied in metric space that every open sphere is an open set. Every open sphere is an open set. So S epsilon by 2x and S epsilon by 2y, which are two open spheres, are open sets. Since X and Y are distinct points, so these two are distinct spheres. So there is no any common point among these two spheres. So F epsilon by 2x intersection F epsilon by 2y is equal to 5. It is proved that is G intersection is equal to 5. G intersection S is equal to 5. So it is a Housdorff space. Suppose if not so, then there exists an element T which is common among them. It means T belongs to S epsilon by 2x and T also belongs to S epsilon by 2y. But since it is open sphere and every open sphere is an open set, so S epsilon by 2 is an open set. And what is open set? Open set is the set of interior points. So T is the interior points of this sphere and T is also the interior points of this sphere. For interior points, the distance between center and the point T must be less than radius. So this point T and X, the distance between T and X must be less than epsilon by 2. Similarly, the distance between Y and T must be less than epsilon by 2. So now dxt is less than epsilon by 2 and dyt is less than epsilon by 2. Now epsilon is equal to dxy, which we have considered here epsilon is equal to dxy. But in metric space, the property of technical properties of metric space is that dxy is less than equal to dxt plus dy So epsilon less than equal to dxt, but dxt is less than epsilon by 2. So epsilon less than epsilon by 2. Similarly, dt by less than epsilon by 2. The epsilon is less than epsilon by 2 plus epsilon by 2. This implies epsilon less than equal to epsilon. Epsilon by 2 plus epsilon by 2 is equal to epsilon. So epsilon is less than epsilon. Epsilon is less than epsilon, which is not possible. Any number is not less than it to itself, which is a contradiction. And this contradiction arises due to our wrong supposition that there is a common point among s epsilon by 2 and epsilon by 2y. There is a common point s epsilon by 2x and s epsilon by 2y. This is our wrong supposition. So there is no common point among these two open spheres, these two open sets. So s epsilon by 2x intersection f epsilon by 2y is equal to 5. Since it's open sphere is open set, so G is the open set, that is also open set. G intersection x is equal to 5. Just sort of thought like this. This is a strong point of the equation of Housdorff space, that G intersection x is equal to 5. S epsilon by 2 intersection s epsilon by 2y is equal to 5. S epsilon by 2x intersection s epsilon by 2y is equal to 5. So it is a Housdorff space. What we have to prove, we already proved it. And theorem is complete now. Thank you. If you like the video, then just subscribe it and press the bell icon and press the like button and share it also.